Hello my friends, this is a very extraordinary lecture because there is a bad situation in Armenia, and in each moment I'm being in a hospital as you see. So today we will continue about the second part of the lecture of general pathogenesis. So at first part we speak about the stage and condition about in acting in a disease stage. And now we will speak about abilities of organism, which is more important to understand in a pathological condition. So as the last slide of the last presentation about general pathogenesis is finished from the on a slide we speak about non-specific reactions in organism, non-specific symptoms, which is becoming non-specific symptoms. Non-specific reactions are very important for understand the general symptoms which is coming in each patient. So we do not find something special in a non-specific reaction. It is coming from the ability of this organism and the ability of the human organism or general organism to defense against the bad forces of a disease, of etiological factors. Okay, so what an interesting thing that there is the signs are different. One type of a disease which called the regulation disorders disease. This type of disease is essence of this disease is broken. The regulation system become the symptoms like disease, and mostly it produce the symptoms of a non-specific reaction of organism, which is we see in any kind of for example, infection or other type of a disease. So it is very important to distinguish this type of pathology symptoms and pathologies, and understand very little things, very little but very important approach for the difference between the signs of pathological process and signs of the non-specific reaction of organism. Okay. Let me sometimes read the text and explain for you the ideas, and sometimes I will show you as an examples. Okay. So the biggest part of the non-specific reaction and biggest essence of non-specific reaction is compensation and adaptation. We spoke about in the last slides about compensation and adaptation. They say that there is a difference. Show there is a differences, but in general say that adaptation and compensation is acting as one specific ability of this of the organism. Yes, same ability is produced in one condition as adaptation, but in pathological condition as a compensation. So there are two stages of development: formation, adaptation, and compensation. Each type of adaptation is being in two stages. The first stage is immediate adaptation, fast adaptation to the affection on the organism, and the long-term adaptation and compensation stage. So, the stage of immediate adaptation, there is a mobilization of existing mechanism and reserves as a result of which the load on until of a functioning system increase its hyperfunction develops. So it is a very easy. I think it's not how is going on. The action of a pathological factor when it's affecting on an organism, it's a violation become a violation of homeostasis. This perception of impaired homeostasis in this stage, when the violation is homeostasis, so organism is understand something is broken. So activate the regulatory system, which is mostly important. Is in general they think there's endocrine and the nervous system, but also their scientists are difference also connective tissue regulatory systems, and has a immediate defense reaction against these disorders, and hyperfunction or relevant structures is became. Okay, so in pathological condition, the compensation is you can see that, for example, enhanced one functional system and decrease other functional system. So the increase of one functional system is sometimes being as a compensatory for doing something good for the organism. Okay, so long-term adaptation and compensation stage, second part, long-term. Okay, at first the fast, then the slow. Okay, the basic is an increase in the capacity of the system responsible for adaptation and compensation. This is achieved by increasing the number of structures that provide hyperfunction, hypertrophy develop. In this case, the load on until of a functioning system decreased to the norm. Let me explain a little bit in other words. Okay, when the one function is being in hyperfunction, one system is working more. Yes, impaired intracellular homeostasis became. Okay, so it is activate the genes, and activation of genes produce the increased synthesis of the proteins and mitosis, and it's becoming to one cell because it's functioning harder. He is becoming or hypertrophy, it's biggest in his size for doing this hard function, and or he's dividing, and we see the hypertrophy of the organ. Okay, let's note that in a hypertrophic condition, function becoming in a normal stage. So when organ is hypertrophic, function is becoming a normal. When organ is not hypertrophic, he can work fast. So it has its logical level. Second ability which I want to speak now, this is concerning about to minimization principle. Let me read and then explain. During normal life, the optimal efficiency of the processes, internal and external, is carried out with minimal energy consumption. This principle subordinates in itself all the order principles and mechanism of the organism is vital activity which normally consume energy in quantities corresponding to the needs of the organ or system functioning at the moment. Okay, good. Look, so it is very easy because each organ take the energy how he's want, how he's doing for his work. The exception in for example in pathology, when we speak about the tumor, we say that in tumor condition, tumor cells take the whole energy in the organism and take a toxin, and by the toxin is making a toxicity of the organism. Okay, but this rule is mostly important in physiological condition because each cell trying to do a harder work with consumption of a little bit energy. He's driving to be take a little energy and doing must work. Okay, so the mechanism of minimizing structures is that with the limited supply of energy from the outside, in order to provide energy for the activity of the elements functioning within the adaptation norm with an increased load, the body redistributes its own energy within the existing energy balance. This redistribution